But I asked the question, why is it that it goes up and down once each year? And he explained that if you look at the land mass of the Earth, very little of it is south of the equator. The vast majority of it is north of the equator, and most of the vegetation is north of the equator. And so when the northern hemisphere is tilted toward the sun, as it is in our spring and summer, the leaves come out and they breathe in carbon dioxide and the amount in the atmosphere goes down. But when the northern hemisphere is tilted away from the sun, as it is in our fall and winter, the leaves fall and exhale carbon dioxide and the amount in the atmosphere goes back up again. And so it's as if the entire Earth, once each year, breathes in and out. So we started measuring carbon dioxide in 1958. And you can see that by the middle 60s, when he showed my class this image, it was already clear that it was going up. I respected him and learned from him so much. I followed this. And when I went to the Congress in the middle 1970s, I helped organize the first hearings on global warming and asked my professor to come and be the lead-off witness, and I thought that would have such a big impact we'd be on the way to solving this problem, but it didn't work that way. But I kept having hearings, and in 1984 I went to the Senate and really dug deeply into this issue with science roundtables and the like. I wrote a book about it, ran for president in 1988, partly to try to gain some visibility for that issue. And in 1992, went to the White House. We passed a version of a carbon tax and some other measures to try to address this. Went to Kyoto in 1997 to help get a treaty that's so controversial, in the U.S. at least. In 2000, my opponent pledged to regulate CO2, and then that was not a pledge that was kept. But the point of this is, all this time, you can see what I have seen all these years. It just keeps going up. It is relentless. And now we're beginning to see the impact in the real world. This is Mount Kilimanjaro more than 30 years ago and more recently. And a friend of mine just came back from Kilimanjaro with a picture he took a couple months ago. Another friend, Lonnie Thompson, studies glaciers. Here's Lonnie with a last sliver of one of the once mighty glaciers. Within the decade, there will be no more snows of Kilimanjaro. This is happening in Glacier National Park. I climbed to the top of this in 1998 with one of my daughters. Within 15 years, this will be the park formerly known as Glacier. Here is what's been happening year by year to the Columbia Glacier. It just retreats every single year. And it's a shame because these glaciers are so beautiful. But those who go up to see them, here's what they're seeing every day now. In the Himalayas, there's a particular problem because 40% of all the people in the world get their drinking water from rivers and spring systems that are fed more than half by the meltwater coming off the glaciers. And within this next half century, those 40% of the people on Earth are going to face a very serious shortage because of this melting. Italy, the Italian Alps, same site today. An old postcard from Switzerland. Throughout the Alps, we're seeing the same story. It's also true in South America. This is Peru 15 years ago, and the same glacier today. This is Argentina 20 years ago, same glacier today. 75 years ago in Patagonia, on the tip of South America, this vast expanse of ice is now gone. There is a message in this. It is worldwide. And the ice has stories to tell us. My friend Lonnie Thompson digs core drills in the ice. They dig down and they bring the core drills back up and they look at the ice and they study it. When the snow falls, it traps little bubbles of atmosphere, and they can go in and measure how much CO2 was in the atmosphere the year that that snow fell. What's even more interesting, I think, is they can measure the different isotopes of oxygen and figure out a very precise thermometer and tell you what the temperature was the year that that bubble was trapped in the snow as it fell. When I was in Antarctica, I saw cores like this, and a guy looked at it. He said, right here is where the U.S. Congress passed the Clean Air Act. And I couldn't believe it, but you can see the difference with the naked eye. Just a couple of years after that law was passed, it's very clearly distinguishable. They can count back year by year the same way a forester reads tree rings, and you can see each annual layer from the melting and refreezing. So they can go back in a lot of these mountain glaciers 1,000 years. And they constructed a thermometer of the temperature. The blue is cold and the red is warm. Now, I show this for a couple of reasons. Number one, the so-called skeptics will sometimes say, oh, this whole thing, this is a cyclical phenomenon. There was a medieval warming period after all. Well, yeah, there was. There it is right there. There are two others. But compared to what's going on now, there's just no comparison. So if you look at 1,000 years worth of temperature and compare it to 1,000 years of CO2, you can see how closely they fit together. Now, 1,000 years of CO2 in the mountain glaciers, that's one thing. But in Antarctica, they can go back 650,000 years. This, incidentally, is the first time anybody outside of a small group of scientists has seen this image. This is the present day era, and that's the last ice age. Then it goes up. We're going back in time now, 650,000 years. That's the period of warming between the last two ice ages. That's the second and third ice age back, fourth, fifth, sixth, and seventh ice age back. Now, an important point. In all of this time, 650,000 years, the CO2 level has never gone above 300 parts per million. Now, as I said, they can also measure temperature. Here's what the temperature has been on our Earth. Now, one thing that kind of jumps out at you is, well, let me put it this way. If my classmate from the 6th grade that talked about Africa and South America were here, he would say, did they ever fit together? Most ridiculous thing I've ever heard. But they did, of course. And the relationship is actually very complicated, but there is one relationship that is far more powerful than all the others, and it is this. When there is more carbon dioxide, the temperature gets warmer because it traps more heat from the sun inside. In the parts of the United States that contain the modern cities of Cleveland, Detroit, New York, in the northern tier, this is the difference between a nice day and having a mile of ice over your head. Keep that in mind when you look at this fact. Carbon dioxide, having never gone above 300 parts per million, here is where CO2 is now. Way above where it's ever been as far back as this record will measure. Now, if you'll bear with me, I want to really emphasize this point. The crew here has tried to teach me how to use this contraption here, so if I don't kill myself, I'll... It's already right here. Look how far above the natural cycle this is, and we've done that. But ladies and gentlemen, in the next 50 years, really in less than 50 years, it's going to continue to go up. When some of these children who are here are my age, here's what it's going to be in less than 50 years. You've heard of off the charts. Within less than 50 years, it'll be here. There's not a single fact or date or number